In lessons 3 and 4, we just continue our use of the array list and its methods, but we're going to get a little deeper into writing loops, uh, interacting with standard algorithms, reverse arrays. So the focus of lesson 3 is really this concept of traversing an array list. We can use a while loop, we can use a for loop, we can use enhanced for loop. They're all options. We'll take a look at a few different ideas here. To start off, I've gone ahead and I've just created an array list, 20 integers in it, random. They're all going to go from 1 to 100. Okay, and I've named that list. We can use that list in a few of these different methods. So, for example, the first basic example I have here is our average. So we've got all these numbers. What if we wanted to get the average of all these numbers? All right, well, this is really not much different than working with arrays. We just have to change our syntax. So you'll notice that when I wrote my control statement, I can't say nums.length. This is not an array, this is a list. So I said nums.size minus 1. Okay, that's going to be the last valid index of the array list. If I took off that equal sign, I would take away the minus. Okay, but I'm just going to let it go to that last valid index and not go past it. If I was working with an array, you might see a statement here that said something like nums bracket I. That's not an option now. This is not an array. So to get something from the array list, I use the get method. And that's going to allow me to access the number, add it on top of the average. And when I'm finished, I'll just divide by the size as opposed to length, and I'll have determine the average. Okay, so if we want to see this run, easy. We're going to see all the numbers print. If you wanted to get out a calculator and check it, you could, but there's all the numbers. The average, I was expecting something around 50 because the numbers were random, but the fact that it's a little bit higher than 50 is not a big deal. It just means we had a few extra big numbers. Okay. If we ran it again, we'd probably get something different, close to 50. All right. So there's our average. Here, this one's a little bit trickier now. This one is definitely another favorite of the College Boards. You're almost guaranteed to see on your AP exam, maybe in the free response and in the multiple choice. Uh, says to delete elements during a traversal. Says it requires using special techniques to avoid skipping elements. Now, this is a tough one. I've written a very similar loop, okay? Same loop, actually. So I'm going to every index of the array, and I've asked the question, is the number at that index an even number? And if it is, I'm going to remove it. So here's my question for you. Did it work? That means if I looked at this list, I shouldn't see any even numbers. Oh, I do see some even numbers. I see an even number 96, really bizarre. I see another one, 84. Why did it not remove 96 and 84? 96 mod 2 is 0, so is 84. The computer doesn't make mistakes, so there must be something wrong with my code. Okay, well, let's take a closer look at that array list that came out of there. This was the original array list. And so if we took those numbers and just right here so we can kind of focus on them, our loop started off going through those indexes, and it went along and, it saw that 71 at index 0 was odd. It got, it's no big deal. Did the same thing when it got to index 1, left it alone. Okay. Got to the 28, and what happened was 28 was an even number. So it removed 28. Something weird happened though. Notice how when I removed 28 from the list, the 73 shifted over and took its spot. Now, my for loop at that moment actually did something also. It went ahead and it moved on to the next index, which in this case was 3. Remember, these indexes that I'm writing here kind of represent our I values, okay? So originally I was 0, that was the 71, then it was 1, and it was 19, then it was 2, and then remember why this worked, okay? There was a 28 there. So when I took index 2, it saw 28 and removed it. That caused all of the numbers in the array to shift left, and the I value went up to 3. Now, as a result, that means that we never checked if 73 was an even number, which it wasn't. So we left it in the final answer. It was no big deal. It didn't end up mattering. Okay, now took the 6 out, same thing happened. That 49 shifted over, okay? But the I value went up to index 4, so we never actually asked if 49 was even or not, but it didn't matter. Well, now it's about to matter. When I gets up to the value of 4, okay, what happens is I equals 4 removes the 78 because nums.get4 shows an even number. When the 96 slides into that place and the I index moves over to index 5, we never asked if 96 was an even number. We skipped right past it. And that's the reason why 96 actually remained in the array list. And then we saw the 17 and the 49 and the 73. Okay, those numbers were odd, so they didn't get removed. Same thing happened over here with that 94-84 combination. Once we got to that 94 and we removed it, the 84 slid over to take its spot, but the index moved up to the 85, and that's why the 84 got left behind. Another interesting thing to note is that even though we started with 20 numbers, the array list didn't finish with 20 numbers. You might think that would cause like an out of bounds exception, but it actually doesn't. And the reason is if you look at how my control statement's written, it's updating continuously. So even when we get over originally it looked like the loop was going to run from 0 to 19. But by the time we got over there, since we had taken out some of the even numbers, like we took out the 92, we took out the 94, but remember the 84 did get missed. We actually only ended up with 15 numbers. So like 5 of the indexes were gone. But we didn't get an out of bounds exception because what happened was after I was 14, it reassessed and it saw that the size of the list had changed, so it didn't like push forward. Now, that was just one example. Let's run it again. Let's see what happens. Let's see if it misses any other even numbers. And well, sure enough, it did. It missed that 82 and it missed that 2. Okay. So notice the 82 got missed because it was next to a 76. So the same thing. When we took out the 76, the 82 slid over. And the 2 got missed because when we took out the 36, the 2 got shifted over. So yeah, it happened again. And it's probably going to continue to keep happening as long as we use this loop. There's a few different ways that we could handle this. Okay. One way to handle it, and this is kind of weird, but I could change this around to be a backwards structured loop. Okay. Start at size -1. I'll work my way back to 0, and I'm going to include 0 because 0 is a valid index of this array list. And I'm going to go to a minus minus. This is actually going to work. Believe it or not, just changing the direction of the loop is going to avoid that problem. Let's take a look and see why that is. Okay. So here's my original array list. All of the even numbers are now gone. In fact, there's a lot of them this time. So we definitely needed a different plan because notice that we got a lot of different array values this time, number values. Okay, so here's the difference. I hope my indexing is still lined up. It looks pretty good. Okay, so the last valid index is 19, and now that's where my loop started. So first I asked about 81. Is it even? No. 73? No. 26 is even. But when I remove 26, remember, right now the index I is 17. We have a minus minus step expression, so the next index will be 16. So if you take out that even number, and then your I value shifts well, no, we didn't skip anything. We hadn't asked about 13 yet. So we're good. Okay, stays. Oh, look at all these even numbers coming up now. 38, gone. The next index is 11. 50, gone. But the next index is 10. Gone. But the next index was 9. Gone, but the next index is. So as you start removing these numbers, the index is actually moving in the same direction you are. And so even though there was that big run there of even numbers, it was kind of a weird test case that I had. It didn't matter. Like we still got rid of all of them. So notice nothing got left. All those even numbers got taken out. Even that big run of even numbers that was in the middle, they all got removed because even though when I removed the numbers, some of the values shifted right, I had already asked about those numbers. I started on the far right. So I never missed anything. So sometimes when you write a remove method, a backwards loop is a great way to go. Okay. So that's, you'll probably see me do that a lot, like if we're doing remove methods. Another real common way to write this is to use a while loop. Now, why a while loop? What advantage does it have? The while loop allows you to take a little bit more control of the step expression. So I'm going to run this from left to right, kind of like my original for loop did. And I'm going to go until we get to the end, num size -1. Okay. But the difference is now, as I start to write this while loop, I'm going to take a little bit more control of the step expression. I'm not going to step forward every time. In fact, when I remove a number, I'm going to let the I index stay the same. I'm only going to move the I index to the right when I don't remove a number. And the reason is when I remove numbers from the list, remember all the numbers to the right of that shift over anyway, so we might as well just stay put, right? There's no reason to progress and traverse to the next element. The element's going to come to us. When we don't remove something, hence odd number, that's when we want to say, okay, that one didn't work. Let's go to the next one. This should remove all of the even values from our array list. Let's see if it does. Of course it didn't, because I think the problem is that if I'm going to use I can't call my future variables I. So I'm sorry, that nothing to do with the while loop. That's just me using I too many times. So sorry about that. Let's see what happens now. I hate it when this happens, but same thing happens to me. So let's just try one. Let's see. It looks good. I don't see any even numbers there. Let's see if there would have. Yeah, see right here, this 74 and 6. That would have been a problem for us before, but the while loop handled it just fine. Okay, so and right here there was a 46, 26, and it got both of them as well. So a while loop's nice because it gives you a little bit more control. I could do the same kind of thing with a for loop too. So I mean, I'm sure that some of you can figure this out. But like if we really wanted to push forward, and use a for loop, we could. Um, the one thing you'd have to do then is if you were going to write a for loop, kind of like what I'm doing right now, just instead of an else statement, what I'm going to do is I'm going to brace my if statement. And so when I do remove something, I'm going to draw the index back. Okay. So imagine like right here, if we brace this, and then we could put in maybe like after we remove, maybe a minus minus. Okay. And then that way we're kind of acknowledging the fact like, okay, when I removed, everything's coming back one. So I don't want the index to step forward. So I'll step it back and then forward and it'll kind of undo what it just did. It'll end up in the same spot. So I should have missed the 36, but notice that it didn't. Okay. I would have missed the 40 with my old code, but it didn't. I would have missed the second 50, but it didn't. So this is another way to do it. So 3 different ways you can do it there. I'm sure you can probably come up with your own. All right. But make sure you always include some sort of strategy like that when removing. Also, sometimes when you add things to lists, you can run into the same kind of problem. In fact, you might get an infinite loop. So if you're adding things, depending on how you're doing it, it might actually trigger some sort of infinite loop structure where you're adding and then you never reach the end because of how that size method keeps updating. Okay. Just like with arrays, we have to be careful that we don't go out of bounds. Okay. So if I wanted to do something like, are any side by side values equal each other? and I'm going to include like maybe an I plus one, I've got to back that index up one extra. Or, another approach here would be to start my loop at index one and then look from, right to left. So when you're going to do things like this, you just always have to be cautious that you're not traversing out of bounds. Okay, so in this example here, I was trying to see if there was ever side by side values that said false. There weren't values that were equal. Now, one final word of caution. I haven't shown you any enhanced loops yet. You can use enhanced loops, they're great. But you might not want to use an enhanced loop if you're changing something. Now, if the object is mutable, you can access it and mutate it. However, if you're looking to add or remove to an array list, you never want to use an enhanced loop because you can get a concurrent modification exception on a strange error. So what I've done here is I've written a loop that said, all right, let's remove all the even numbers. Okay. Well, for this to work, I think I'm going to have to put the even numbers back in. So let me make sure that this part's off. Okay. And now if I try to remove an even number from the list in an enhanced loop, I get a concurrent modification exception. So you're allowed to remove even numbers, right? We just did it. But you have to use an index loop to do so. You're using an enhanced loop and you're saying like, I want to take this object reference out of the array list, you can't use an enhanced loop. So earlier when I was removing numbers, I was careful to not use an enhanced loop. You actually get a similar error if you try to add. So this time I'm saying if the number is odd, I want to add a 13 to the end of the list. Now this is risky because again, this is a case where I might create an infinite loop if I start adding odd numbers to the end of the list. So let's go ahead. Let's say that I didn't put an odd number. Let's say I put a 0. Then this shouldn't be an infinite loop case, but I might get this current modification exception. And yeah, I did. So you don't want to try to change the size of a list from an enhanced loop. Okay. If you're ever looking to change the size of the list, adding or removing, you should use an index loop to avoid the current modification exception error. All right. Check out these array list exercises on Practice It and let me know if you have any questions.